Size of a peppercorn, the sun would be a ball of gas roughly the size of a bowling ball, and it would be 26 meters away. Jupiter would be a chestnut more than 100 meters away. Pluto would be a grain of sand located a full kilometer away. And in between these tiny specks of matter, there would be nothing but empty, silent air. This is why we need light to measure even our own backyard. We need a ruler that can span the silence. And so we begin to measure not in years, but in seconds and minutes. This is the training ground. This is where we learn that looking at the sky is an act of waiting. Let us start with the closest world to our own, the moon. It hangs in the night sky, large and luminous, covered in the gray scars of ancient impacts. It feels like a companion. It controls our tides. It lights our paths. It watches over us while we sleep. It feels near. And in cosmic terms, it is. But even this nearest neighbor is separated from us by a chasm of emptiness that defies easy travel. The Apollo astronauts, strapped into the most powerful rockets ever built by human hands, took 3 days to cross that gap. 3 days of drifting through the blackness. 3 days of silence. But light is faster. Light does not drift, it rushes. When we look at the moon, we are seeing light that left the lunar surface just over 1 second ago. 1.3 seconds to be precise. It is a distance of about 384,000 kilometers. In the time it takes to take a single deep breath, light can make that journey. It is a light second. This is a manageable unit. We can feel a second. We can understand it. It is the duration of a heartbeat. It is the time it takes to blink. When the astronauts on the moon spoke to Mission Control in Houston, there was a pause. They would say something, and their voice, carried by radio waves which travel at the speed of light, would take just over a second to reach Earth. Mission Control would hear it and answer immediately, but their answer would take another second to travel back to the moon. The result was a conversation filled with small, unavoidable gaps, a rhythm of waiting. Silence, voice, silence, answer. That silence was not a technical failure. It was the physical manifestation of distance. It was the universe gently reminding us that even close neighbors are not in the same room. Now let us turn our attention inward toward the center of our system, the sun. It dominates our sky, burning with a ferocity that sustains all life on our planet. It looks like it is right there. We feel its heat on our faces the moment we step outside. But that heat is an illusion of immediacy. The sun is 150 million kilometers away. It is a distance so vast that a commercial jet flying without stopping would take nearly 20 years to reach it. 7. Light, however, makes the journey in 8 minutes and 20 seconds. This is a light minute. It is a scale that fits into a human routine. 8 minutes is the time it takes to boil a kettle and make a cup of tea. It is the time it takes to listen to 2 slow songs. It is a short walk around the block. In that brief span of mundane time, light has crossed the cold, dark void between the star and the planet. It has raced past the orbit of Mercury, past the thick clouds of Venus, and arrived at our atmosphere. There is a strange and beautiful thought that comes with this delay. When you watch the sunset, when you see that great orange sphere touching the horizon, dipping below the edge of the world, you are watching something that has already happened. The sun has already set. Physically, geometrically, it is already below the horizon. But the light carrying the image of the sun is still streaming toward you, 8 minutes behind reality. You are watching a ghost. You are watching a memory of the sun. The universe is playing a trick on your eyes, preserving the moment for just a little longer than it actually existed. As we turn our backs on the sun and look outward into the deeper dark of the outer solar system, the light minutes begin to stack up. We move past Mars, the red planet. Depending on where Earth and Mars are in their orbits around the sun, the distance between them changes. Sometimes they are close, sometimes they are on opposite sides of the star. The time it takes for light to travel to Mars varies from about 3 minutes to nearly 22 minutes. Think of the rovers that crawl across the surface of Mars right now, robot explorers dusting the red soil. When engineers on Earth send a command to tell a rover to turn left or to take a picture, they press a button, but nothing happens. The signal leaves Earth, flashing out into the void at the speed of light. It travels for 10, maybe 15 minutes. It crosses millions of kilometers of nothingness. Finally, it arrives at Mars. The rover receives the command and turns left. It sends a signal back saying, "I have turned." That signal takes another 15 minutes to return to Earth. For the engineers sitting in their chairs, a full half hour has passed since they pressed the button. They have to wait. They have to trust. They have to accept that they are not driving the rover in real time. They are guiding it through a delay. They are interacting with the past. This is the lesson of the solar system. The further you go, the deeper into the past you must reach. Beyond Mars, the distances expand dramatically. We reach the realm of the gas giants. Jupiter, the king of planets, a swirling ball of storms and clouds so large that it could swallow 1,000 Earths. It sits far out in the cold. Light from the sun takes roughly 43 minutes to reach Jupiter. 43 minutes, that is a lunch break. That is a television episode. It is a significant chunk of an hour. If someone were floating in the clouds of Jupiter, looking back at Earth with a telescope, they would not see us as we are now. They would see us as we were 43 minutes ago. They would see us doing things we have already finished doing. Then comes Saturn with its magnificent icy rings. Saturn is nearly twice as far from the sun as Jupiter. The light takes about an hour and 20 minutes to get there. An hour and 20 minutes of silence. An hour and 20 minutes of moving through the dark with no landmarks, no air, no sound. Just the steady, unwavering progress of photons flying away from the sun. And then the ice giants, Uranus and Neptune. These worlds are so distant that they are barely visible to the naked eye, faint points of light lost among the stars. Sunlight takes nearly 2 hours and 40 minutes to reach Uranus. It takes over 4 hours to reach Neptune. 4 hours. Imagine standing in the sunlight at noon. That same light, that same pulse of energy will not touch the clouds of Neptune until 4 o'clock in the afternoon. It is a journey that spans half a workday. By the time we reach Pluto and the scattered icy rocks of the Kuiper Belt, we are 5.5 hours away from the sun at light speed. The sun from Pluto is no longer a blinding disk. It is just a very, very bright star in a black sky. It provides little heat. The daylight on Pluto is weak and watery, like the light of dusk on Earth. The delay is profound. A message sent from Earth to a probe near Pluto takes 5.5 hours to arrive. A round trip takes 11 hours. You could send a message in the morning, go about your entire day, eat dinner, and get ready for bed before the reply returned. This is the scale of our own neighborhood. It is measured in hours. It is vast, yes. To a human being, it is inconceivably large. But to the universe, it is nothing. It is a speck. It is a grain of dust. Because even at Pluto, even at the edge of the darkness where the sun's influence begins to fade, we have not yet reached a single light year. We haven't even come close. A light year is not 5 hours. It is not a day. It is not a week. It is a year. 8,760 hours. To reach 1 light year, you would have to travel the distance from the Sun to Pluto roughly 1,600 times. You would have to stack 1,600 solar systems end to end just to span the distance that light travels in 1 year. And remember, the nearest star is over 4 light years away. This is where the brain begins to stumble. We feel like we have traveled a long way just to get to Pluto. We have crossed billions of kilometers. We have passed giant planets and asteroid belts. We have spent hours moving at the speed of light, and yet we have barely left the driveway. We are still standing on the doormat of the cosmos. The distance between the edge of our solar system and the very next star is a void so deep, so wide, and so empty that it makes the distance between the planets look like a crowded room. In that void, there are no planets to mark the way. There are no rest stops. There is only the drift. There is only the long, silent glide through the interstellar medium, the thin soup of particles and dust that fills the space between stars. This is where the light year truly begins to matter. It is where light minutes and light hours become too small to be useful. We need a bigger ruler. We need a ruler that can handle the silence of the deep ocean. Consider the Voyager probes, Voyager 1 and Voyager 2, launched by humanity in the 1970s. They are the fastest objects ever built by human hands. They have been flying for over 45 years. They have flown past Jupiter, past Saturn, past Uranus and Neptune. They have left the planets behind. They are moving at roughly 60,000 kilometers per hour, a speed that is terrifyingly fast by Earth standards, and yet in light years, they have traveled nowhere. They have traveled less than 1 day of light time. They have been flying for nearly half a century, and they have not even covered the distance light covers in 24 hours. If Voyager 1 were heading directly toward the nearest star, which it isn't, but if it were, it would take over 70,000 years to get there. 70,000 years. That is the difference between chemical rockets and the speed of light. That is the difference between human movement and cosmic scale. It is a reminder that we are slow and the universe is big. But there is a comfort in this slowness. There is a peace in knowing that we cannot rush. We cannot force the universe to be smaller than it is. We can only watch it. We can only listen to it. The solar system, with its light minutes and light hours, teaches us patience. It prepares us for the longer waiting that is to come. It teaches us that separation is natural, that delay is built into the physics of reality. When we look at Saturn, we are waiting for an hour. When we look at Neptune, we are waiting for 4. We are practicing. We are letting our minds stretch, slowly, gently, like a muscle warming up. We are getting ready to look beyond the edge, into the true dark, where the light takes not hours, but years and centuries and millennia to reach us. So let us rest here for a moment. Let us drift in the space between the planets. Let us float in the 4-hour gap between the Sun and Neptune. It is quiet here. It is calm. There is no wind. There is no noise. There is only the faint, distant warmth of the star and the endless velvet black of the vacuum. We have learned the scale of minutes. We have learned the scale of hours. We are ready now to turn our eyes outward to the places where the calendar becomes the clock and the light year becomes the only way to speak of the distance home. 10. The ocean between the islands. We have left the planets behind. We have drifted past the icy giants, Uranus and Neptune, and we have floated silently through the scattered debris of the Kuiper Belt, where Pluto and its frozen cousins wander in the dark. Now, we are crossing a boundary. It is not a solid wall, nor a line drawn on a map. It is a fading. It is the place where the wind from the sun, the stream of charged particles that blows outward from our star, finally loses its strength. It pushes against the thin, sparse gas of the galaxy, and it falters. This is the edge of the heliosphere. This is the true border of our home. Beyond this point, we are in interstellar space, the space between stars. If the solar system was a house, we have just stepped off the front porch and into the night. And the first thing we notice, the overwhelming sensation that defines this new realm, is emptiness. When we were near Earth, space seemed busy. There were satellites, debris, the moon, the other planets visible as bright wandering lights. Even in the outer solar system, there was a sense of structure. We knew the sun was there, holding everything in place with its invisible gravitational tether. But here, in the deep void, that structure feels distant. The sun is just a star now. It is the brightest star in the sky, yes, but it no longer merging into the backdrop of the Milky Way. We are entering the ocean between the islands. The distances here are so vast that they defy the analogies we used before. We spoke of light minutes and light hours. Those units are now too small. They are like trying to measure the depth of the Pacific Ocean with a teaspoon. We must switch to the light year, and even then the numbers are humbling. The nearest star system to our own is the Alpha Centauri system. It is not a single star, but a family of 3. There is Alpha Centauri A, a bright yellow star much like our sun. There is Alpha Centauri B, a slightly smaller orange star. And there is Proxima Centauri, a small, faint red dwarf that circles the other 2 from a great distance. Proxima is the closest of them all. It is our nearest cosmic neighbor, and it sits at a distance of roughly 4.2 light years. 4.2 light years. Let us hold that number in our minds. It sounds small. 4 is a small number. You can count to 4 on one hand. But remember what a light year is. It is 9.5 trillion kilometers. It is a year of continuous, breathless speed. To say that Proxima is 4 light years away is to say that light, the fastest messenger in the universe, must travel for 4 years, 2 months, and a few weeks without stopping, just to cross the gap. Imagine a beam of light leaving the surface of Proxima Centauri. It flashes into existence, born from the swirling plasma of the star. It flies outward, escaping the star's gravity, and enters the void. For the first year of its journey, it encounters nothing. It flies through absolute darkness. There are no planets to pass, no asteroids, no dust clouds large enough to matter. It is just the photon and the silence. A year passes. On Earth, the seasons have turned. A birthday has come and gone. The light is still traveling. It has covered 9.5 trillion kilometers, and it is still in the middle of nowhere. It is not even halfway there. A second year passes. The light rushes on. It is utterly alone. The silence of interstellar space